Okay, friends, I think today we will start to solve the example which is slightly in different variety for the method of superposition. So we'll solve the example in today's class. So far we have been dealing with the examples where you have the redundant forces or redundant moments as your unknown forces, as your additional unknown forces. So we have seen couple of examples. One, we started with a very simple example, that is prop cantilever. Then we saw the example which is related with fixed end beam. Then we also saw the example which is related with here there is a hinge support, roller support and roller support here, like type of example that we have seen. So in all these kind of examples, whether it is single degree of indeterminacy, static degree of indeterminacy, single degree of static indeterminacy. Sometimes in these examples we have seen that there are two static degree of indeterminacy. And in this also, when there are multiple degrees of, this is the example also of the single degree of indeterminacy. And there are multiple degrees of indeterminacy. For example, this is an example where we have taken, like there are four unknown forces, only two equilibrium equations, and we have to choose the choice of redundant that depends on the person who is actually analyzing the example. So we have this same example, we have done it in a two ways. One, we have taken the MA and MB as your redundant, because whatever the excess forces are there in addition to the equilibrium equation, unknown forces you have to remove. Okay, and you can make the structure statically determinate, and then one by one you apply the unknown forces in as an external load, which are your redundant forces one by one. So this example we have also seen, if you can take the redundant forces, that is R B and MB as your redundant forces. So in that case beam becomes cantilever. In this case, when you are taking MA and MB as your redundant, it becomes simple support. Right here it becomes cantilever if you are taking RB as your redundant. You may also choose in this same example MA as your redundant forces. Okay, so that exercise itself I have given you in the example and the homework. I hope all of you are following that. And here if you take MA, then of course your beam becomes simple support as your redundant force, but if you take RB, then it becomes cantilever beam. So in this type of example, the third case where we have taken removing this support, that is vertical reaction RB as your redundant force. So now slightly different variation where you can also take the redundant as your internal moments or internal shear forces. So slightly different variation, which I have also included in your assignment example, which I have uploaded yesterday. When your internal moments as your redundant forces. So BTech 3-span continuous beam. This beam has several supports, 3 roller and 1 hinge support. Of course, axial forces are neglected, and this beam is having the loading like concentrated loads. And we have UDL. So let us name it A, B, C, and D. And we may take the length as L, L by 2, L by 2, L by 2, L by 2. So just observe this problem. One possibility is always there, because how many static degree here? Of course, there are 4 supports and we are neglecting, of course, there are 2 forces here, but we are neglecting horizontal, and there are 3 reactive forces here, support reaction. So total 4 unknown reactive forces. But only 2 equilibrium equation. So of course, static degree of indeterminacy is 2. So I have a choice. That simplest choice here is I can always choose RB and RC by removing redundant forces RB and RC. I always have this option. But I don't want to choose that, because I already know how to do that, because in the process, how will you follow that? If I choose RB and RC, what you do? You simply remove this support, makes the structure, simple beams with, of course, loading. In first case, you can always make the structure statically determinate, and then you apply one of the redundant force 1 by 1 as your external load. So in the second case, I apply RB. Okay, and I find out the deflection here. Here there will be a deflection. So I have here delta 1, delta B1. Here I have delta B2. And then second time when I take the RC as your redundant, and it will definitely going to deflect in upward direction. And in the process, you can, of course, here you can calculate delta C1. Here you can calculate delta C2. Here you can calculate delta C3. Of course, you can here calculate delta B3. So if this is the case, and then I write the compatibility equation by superposing the deflection that is at joint B, that is at support B. Here I try to superpose this deflection and write joint B compatibility equation. And then second time I write, joint C compatibility. So finally it becomes, delta 1 B plus delta B 2 plus delta B is equal to original beam on vertical support. There are no deflection. Okay, by the way, just to mention you that in the exercise I have given one example of the support settlement. So support settlement is what? Let's say support joint B is allowed some deflection, let's say 30 mm. It is already there in the construction practice where you allow some of the joints already some displacement or the settlement. So in that case, this support, though it is a roller support, I know that vertical deflection is 0, but this support has settled 30 mm. So that case you can't make it 0 here. So यहाँ पे आपको 30 mm equate करना है. So there was one example in the assignment. So that is the reason why I am telling you that there is nothing great in that. I mean, it is just a matter of equating that particular deflection which is given in the original beam. So instead of 0, you may write 30 mm. So that is one thing point I wanted to mention. And then of course you can write the joint compatibility equation at joint C. So this way, and if joint C is not supported, then these are two equations. And what are formulas? I mean, you can just check the tables data available with us that under the external loadings, what are the deflections here at joint B and joint C. You can write down the formula. We have been doing this exercise in the past few lectures. And you solve the simultaneous algebraic equation by elimination method. And then you solve for RB and RC. So my final answer, when I solve this equation, I get RB and RC. That is all. Okay. Now, another point I wanted to mention is, in the exercise also I have asked that you find out all the reactions. Okay, तो जहाँ पे भी example में पूछा है all the reactions, मतलब first you have to find these primary unknown redundant forces. Once you find primary unknown redundant forces RB and RC, after that you apply equilibrium equation, that is sigma Fy0 and sigma mz0. So you can take the moment about, let's say, support A0 and considering all forces, all reactions, because now you know this reaction RB and RC already. Okay, and then you can write the equilibrium, because RB and RC will be in the form of external load, that is, it is a function of WP. Okay, external load, these RB and RC I want to put in a function of external load. So once you can find, once you solve this equation, you get your RB and RC in the form of external load. So once you find, you apply equilibrium equation to find out the remaining unknown reaction, that is RA and RD. It is as simple as that. Okay. So यहाँ पे इक्विलिब्रियम इक्वेशन कैसे लिखोगे? एक्सटर्न एक साइड में एक्सटर्नल लोड होगा, फिर RA प्लस RB प्लस RC प्लस RD, ऐसे करके आप इक्वेट कर सकते हो with the external load, and then RB and RC is known, then you can definitely again RA and RD. या सो इसमें भी हमें एक इक्वेशन ये मिलेगा, दूसरा इक्वेशन आपको सिग्मा mz is equal to 0 उससे मिलेगा, and then those two simultaneous equation you solve it for RD, RA, RD. Okay, so it is not a break deal. And once you know all the reactions, because I have mentioned in the assignment also that you plot the bending moment and shear force diagram, so that we will see. I think we will solve one example in the class, but before that you try. The procedure is, because you already studied bending moment shear force diagrams, once you know all the reactions, okay, once you know all the values of the reactions, I can always plot the bending moment and shear force diagrams. So there are 3 steps in entire process for solving these assignment exercises. One is, first you find static degree of indeterminacy and choice of redundant. I am repeating few things because then you don't have any difficulty in solving the assignment also. Second, you have to make the structure statically determinate, and entire process of method of superposition the way we are doing, find out redundant forces. Third step is find out redundant forces and from the compatibility equation. And third is use equilibrium equation to determine remaining unknowns. And finally, fourth step is, of course, here method of superposition you have to apply. And the fourth step is plotting PMSF. So this completes entire analysis, because finally when you have next semester the subject like design of structures. So before designing any structure, you should know these bending moment shear force values, and of course the critical values, मतलब कहाँ पे maximum or minimum value of the bending moment and shear forces are there. So the whole exercise, you may also write the fifth point of co-critical. So उसमें आप, there is a systematic procedure we will also discuss. If you take the differentiation of the moment, then you find maxima and minima. You take the moment equation, and then you can find the critical points where the bending moment is. You can find out the distance where the bending moment is maximum. So that is also a one step, important step. So entire thing will complete your structural analysis. So everything you should know by heart. You should know by heart everything. Okay, you cannot skip anything here. Being a civil engineer, you should know till the final step. Final step is this: what's the maximum bending moment shear force values? Because that is going to be used for the design. Okay, and that is the reason why we are emphasizing so much on, I am telling you again and again, we will practice. If you need revision, we will do even the bending moment shear force diagram, everything we can design. I know it is difficult, it is, but once you understand, I don't think you will have any problem with that. Okay, so as I mentioned to you, instead of now RB and RC as your redundant, we may choose the internal bending moment as your redundant, and how we can incorporate this into our analysis. So we solve the same example. We discuss the same example by considering, instead of RB, RC as your redundant, we choose internal moment. Okay, so how to choose that? So because see, in this beam, I'll read the diagram. In this beam, this is a continuous beam. The meaning of continuous is, though internal there is a hinge support here, bending moment is not zero here. Let me tell you. If you analyze this example, internal support, because extreme end support, roller and hinge, bending moment will be zero. Because that is the reason you are applying that formula. Na? These two formula you have used. Bending moment at support B and support A, it is zero. Right, but here, because the internal hinge, though some movement is allowed, but this is a continuous beam. Okay, continuous. So at these two supports, you will, when you plot the bending moment shear force diagram, we will see that that time we will come to know that B or C पे bending moment value is not 0. Okay, so there will be, if you see the bending moment diagram, it will be something like, something like this. I'm just, because I know in advance that bending moment diagram for this particular beam ABCD may be something like this, where the supports, these B and C, support moments are not 0. Let me tell you. Of course, it is from calculation we have to see, but I'm telling you in advance that it is like that. B and C moments are not 0 because we have to provide some continuity, right? Here there is a continuous. Now, if I want to choose the internal bending moment, so यहाँ पे bending moment internal, that is MB at this particular point at B, and MC at this particular point, moment is not 0, and that is the reason why we can choose MB and MC as your redundant internal bending moment. We may choose that because it is not 0. जो 0 नहीं है वो हम redundant choose कर सकते हैं. But how to solve this example? So, if now first thing is I want to make the structure statically determinate by removing this redundant internal moment. What is the meaning? By removing मतलब अगर zero non-zero quantity है तो उसको मैं zero कर सकती, right? So next step will be I want to make MB, MC 0, which are my redundant internal moment, and in the process I can make the structure as released or statically determinate structure. So this we have to keep in mind. जब variety है, this is a different variety. Okay, this is a variety of example. ये अलग category है. तो अगर MB and MC is not 0 at the support B and C, I can choose that as redundant. What do you mean by redundant? Means we have to remove it afterwards for our analysis as a part of method of flexibility and superposition. I can remove MB and MC by making it 0. Now, we have to change the structure in such a way MB and MC are 0. So what I do, I simply introduce internal hinge. So internal hinge meaning there is a discontinuity in the structure. I have introduced rather than continuous. I told you the continuous structure does not have internal moment 0, but here I make deliberately the internal moments as your, यहाँ में internal hinge introduce कर दो, then automatically these three beams becomes statically determinate, all three symbol, so it is converted into equivalent three simple support beams. So when I introduce internal hinge where bending moment should be 0, okay, these are my criteria because I have chosen these as redundant. And how do I make it? I have to make structure statically determinate. That is the first step of analysis, right? You have to make structure statically determinate. So I introduce internal hinge where bending moment is 0. And this is my statically determinate structure. It has converted into three simple supports. And this definitely I can analyze. But analyze for what? Because I have chosen MB as your redundant, I have to calculate rotation due to this hinge support which is internal. ठीक है, like we are calculating rotation here at the end, right, when we have chosen the moment redundant here at the support A in our previous examples. So those who have understood well, they will quickly realize that what exactly we have done. When we have chosen MA as your redundant, I have calculated rotation here, right? So similarly, if I am taking internal, moment 0, then surely I can, calculate rotations for this beam. So the, under the external load, of course, that is the first step, that under the external load, what are the rotations that we need to calculate for these three beams, but only at the junction, that is B and C. So we'll calculate rotations at junction B. So junction B comprises of rotation. You may see here joint B comprises of rotation due to both the span. You have to observe both the span. ये beam से भी आएगा, ये beam से भी आएगा. So AB and BC. So when we refer tables, that time we will calculate the rotation because of first span, plus we will add the rotation because of the second span. Okay, now what about the sign convention? Sign convention is very simple. How will you take, मतलब प्लस लोगे नेगेटिव लोगे, वो आप कैसे डिसाइड करोगे? साइन कन्वेंशन will be based on assumptions that tension in the bottom fibers will give you positive rotations. It is a very simple definition. All of you have studied beam bending. Tension in the bottom and compression on top will be considered for positive rotations. So here whatever rotations are producing, because under the external load, you can see here that this beam is bending like this, tension in the bottom fiber always. Okay, so under the action of this W and P, this is the rotation which is positive. Why? Because it creates tension in the bottom. Even this rotation will be considered as positive. So I will be able to calculate theta 1 due to first span AB due to span BC. Both are tension. Ye second span is also because of the concentrated load. It is going to give you positive rotations here. Positive rotations here. Similarly, at joint C also, of course, there are positive rotations. So we may call it theta 2, 1 due to span BC and theta 2 due to span CD. This is your D, right? CD. So first case is over. Step 1 is over. When I have statically determinate structure, I have applied internal moment as your redundant forces. That means I have removed the moments internal. That means I have introduced internal hinge, which will give you zero bending moments. What is the purpose of hinge, internal hinge? It gives you zero moments. This you have to keep in mind. Internal moment, अगर इंटरनल हिंज है, उसका फंक्शन क्या होगा? बेंडिंग मोमेंट बीच में वो ब्रेक कर देगा, मतलब कंटिन्यूटी ब्रेक कर देगा, बेंडिंग मोमेंट जीरो हो जाएगा यहाँ पे, अगर यहाँ में मैंने इंटरनल हिंज ला ली तो वही हम कर रहे हैं. लेकिन कंटिन्यूस बीम में क्या है? एज आई टोल्ड यू, कंटिन्यूस बीम के अंदर It is not zero. This is continuous. Originally, it is being given as a continuous beam. So these internal moments won't be zero. Internal bending moment won't be zero. But I want to make it zero because I have chosen as my redundant. And that will convert my entire continuous beam into three simple support beams. Three simple support beams. That means I can analyze that using my table or formula or statically determinate whatever given information, prior knowledge which I am already having. So once I am able to do that, I can calculate rotation. So how to calculate rotations? It is based on the sign convention. That is, it will be based on the assumption that tension in the bottom fiber. So I know that under the external load, beam deflects downward. So downward जब deflect होगा, you always have tension in the bottom fiber, right? And compression in the top fiber. So whatever calculations I am rotating, whether it is clockwise, anti-clockwise. I am not mentioning here clockwise, anti-clockwise because here you know that it is anti-clockwise. But here you may see that it is clockwise. You see, these two rotations are anti-clockwise. If you rotate, this is in anti-clockwise, and even this beam, the rotations will be okay. Here also it turns out to be clockwise. Actually, here it will be clockwise because, and here it will be anti-clockwise. Why? Because it is the left support of this beam. So left side है उसमें clockwise होगा, यहाँ पे लेफ्ट साइड में होगा वो एंटी क्लॉकवाइज होगा, मीन्स राइट साइड में है वो क्लॉकवाइज, मीन्स यहाँ पे आपको क्लॉकवाइज मिलेगा और यहाँ पे एंटी क्लॉकवाइज मिलेगा एट दिस ऐसा. So though it is clockwise anti-clockwise, so we can still choose both the things positive. Here also both the things positive. Why? Because tension in the bottom fiber. Okay, now what is the second step? I have to apply redundant as your external moment. So apply redundant moments, internal moments. Here I have to use the word internal moments as your external load one by one. One by one means one at a time, right? One by one, because it's a two static degree. तो हमें one by one apply करना है external load as in your redundant internal moment as your external load one by one, MB and MC respectively. So now I draw the another diagram which will show the clear picture of this. So here you may see now. So I apply in a positive direction only. Positive means जो tension होगा इस दोनों जगह पे, because there are two spans, right? Two spans. So I will apply at one end. Let me call this as your MA. This is your, I have to apply for both the span as your redundant moments, internal moments. जो ये मेरा external load हो गया, तो अभी पूरे ये beam में only these two redundant moments are as your external load. मतलब ये अभी external load जैसे act करेगा. MA जो है हमने दोनों स्पान हमने कंसीडर किए क्योंकि हम ये जो जॉइंट बी है उस पर दोनों स्पान साथ में है, राइट? तो हमें स्पान ए बी के लिए और बी सी के लिए दोनों जगह पे we have to apply the external moment, and then we analyze for the rotation for calculation of this rotation. So here if you apply the external moment, the beam will deflect like this. and I calculate rotations here. However, see here we have taken we have taken external moment as your line with the direction. रोटेशंस में कैसा है, आप जब देखोगे फॉर्मूला दैट टाइम यू विल कम टू नो के अंडर द एक्सटर्नल लोड दिस इज अ रोटेशन, बट I have applied the redundant moment as a sign convention only. So there should not be any confusion. हमने अभी भी यहाँ पे टेंशन इन द बॉटम फाइबर करके ही अप्लाई किया है, जबकि पहले के जो एग्जाम्पल्स थे हमारे उसमें मैंने बोला था कि आप एक्सटर्नल मोमेंट डालते हो तो आप डायरेक्शन उल्टा करके डालो, वो यहाँ पे नहीं है। वो हमें फॉर्मूला देखेंगे हम पता चल जाएगा कि साइन कन्वेंशन हम कंसिस्टेंटली एक ही साइन कन्वेंशन फॉलो कर रहे हैं। ओके, सो हियर स्पेसिफिकली आई एम मेंशनिंग साइन कन्वेंशन. So you may apply reverse also. I don't see any point. You may apply reverse also, but then from the formula it will be the reverse sign. Whatever formula you are picking it up, it will be different, right? So here let us keep right now the consistent sign convention. I have still apply MA, MB, MA as your tension in the bottom fiber. So let us see what happens now. Okay, second step. Apply at the joint B the internal moment. By the way, this is still internal hinge, and you apply, just like tension in the bottom, because this sign convention will give you the tension in the bottom. Okay, so this I'm slightly reverse approach as compared to our earlier examples. Earlier example में मैंने आपको क्या बोला था, सपोज फिक्स एंड था और ये मेरा लोडिंग डिफ्लेक्ट हो रहा है एक्सटर्नल लोडिंग है, तो यहाँ में जो मेरा रोटेशन है वो एंटी क्लॉकवाइज होगा। बट जब मैंने एक्सटर्नल रिडंडेंट फोर्स अप्लाई किया, देन आई हैव अप्लाई in a reverse direction, right? Because this moment will be produced. I have apply in the, of course, in the same direction, just like anti-clockwise. यहाँ पे जो रोटेशन होता है वो क्लॉकवाइज में होगा और मैंने मोमेंट अप्लाई किया था एंटी क्लॉकवाइज, एज्यूमिंग कि जो फिक्स एंड है उसका जो इफेक्ट है वो ऑपोजिट होगा करके. But here slightly just to mention, I am mentioning it again why it is so, it is not going to make any difference. So that also we will mention. When we calculate, write down the formula, that time you will come to know it is not going to make any difference, because ultimately it is the algebra, right? And whatever formula we are picking up, it if it has reverse sign, it is automatically give you the negative rotations instead of positive. So for the time being, just keep in mind that we have changed our sign consistently the same. We have written the same. Okay. So because tension in the bottom fiber, that is already given to me in prior in the example itself. So this is also going to give you tension in the bottom fiber like this. And this is your MB that you are applying as an external moment. Now we write down the formula. So by referring the table, you will come to know that. I'll open that table now. That first we analyze this. So that is under the external load UDL. What is the theta 1? Okay, and theta 1 due to span AB and theta 1 due to span BC. So external or concentrated load के लिए we need to check. So let me take you through that. Table again. Okay, so you may see here. So this was the span AB. Okay, AB, and I want theta B, right? So that is QL cube over 24 EI. So I'll note down that number here. QL cube over 24 EI. That is theta 1 due to span AB. And then I will add, because both the rotations are positive. Why positive? Because tension in the bottom fiber. तो ये टाइप के एग्जांपल में आपको एक ही साइन कन्वेंशन याद रखना है, टेंशन इन द बॉटम फाइबर. सो ऑल आर पॉजिटिव, nothing wrong in that. Okay, and then we will see here. So theta B anyway is positive here, you can see here theta B. And then theta A is with the concentrated low. So you may see here the concentrated load. And I want theta A for this, right? Because left of that span BC, left of the span BC, I want to calculate theta A. So PL square by 16 EI. So I may note down that figure. PL square by 16 EI. So this is, sorry, this is due to theta 1 span BC. So understood? Any questions? Any questions so far?
No, ma'am.
Okay. Now we calculate remaining quantities. So remaining, so okay, theta 2 BC and theta 2 CD भी हम लिख सकते हैं in a similar, sorry, in a similar way. So it is both due to concentrated load. So theta B same है. So what we can write? It is same. Both are same. So theta 2 जो है एक साथ ही लिख रहे हैं, बाद में सुपरपोजिशन के टाइम पे वो सेपरेटली ऐड होंगे. सो थीटा 2 ड्यू टू सॉरी BC will be PL square by 16 EI and theta 2 due to span CD is also, because theta A और B दोनों सेम है, ये देखो यहाँ पे theta A और B सेम है, right? So whether it is left side or right side, the both the rotations are going to be the same. So PL square by 16. Yeah. So one step is over. Now second step, it is simple that you have to analyze this for rotations which are first here theta 2, let's say due to AB, theta 2 due to BC, and this moment MA here in span BC will also produce a rotation here. Okay, so here I also have to calculate theta 2 just a second, the sign convention. यहाँ ओके यहाँ पे थीटा 1 लिख रहे हैं, थीटा 2 बाद में लिखो. सो थीटा 1 लिखो, 1 डैश या ऐसा कुछ लिख दो 1, और वहां पे हम थीटा 2 लिख रहे हैं तो थीटा 2 डैश लिख दो यहाँ पे, थीटा 2 डैश ड्यू टू बोथ द स्पैन दैट इज BC एंड CD. एक केस में AB BC आएगा, दूसरे केस में BC CD आएगा. नाउ यू चेक द टेबल अगेन. सो मोमेंट देखना है मुझे. सो आप यहाँ पे मोमेंट देखो. तो जैसे मैंने कहा था, जहां पे जो साइड में मोमेंट अप्लाई होता है वो साइड में रोटेशन मेरा ml/3EI है, और जो फार एंड है मतलब दूसरे एंड में मेरा रोटेशन हमेशा ml/6EI होता है, उसका हाफ होता है, राइट? यहाँ पे अगर ml/3EI है, उसका आधा रोटेशन सामने वाले बीम पे होगा जब आप मोमेंट अप्लाई करते हो. तो यहाँ में वी कैन सिंपली राइट the rotation that is ml/3EI, ml/6EI. So in this beam at these two junctions there will be two times rotation, the same rotation, because जो side में moment apply हो रहा है due to span AB and BC, I can write that is theta 1 AB, theta 1 dash, right? Theta 1 dash AB. I can always write M0. So instead of M0, I will write MA over L over 3EI plus theta 1 dash due to BC is also the same because the moment is applied at the span left side of that span BC. So 3EI. So this is over. So two times actually MA L over 3EI. But anyway, this is whether we are going to, okay, you may add nothing wrong, you may add this. Now the last case, same way. तो आपको सेम वे ने देखना है, सिर्फ आपको नोटेशन चेंज करना है, दैट इज थीटा 2, okay, we forgot to write this theta 2 dash due to BC, right? So theta 2 dash due to BC and theta 2 dash due to CD. So due to CD, there is no moment. This first case, figure 1, where I have applied only MA, तो यहाँ पे एक रोटेशन आएगा फार एंड पे, तो MA over 6EI, ML over 6EI, बट राइट हैंड साइड में कुछ है नहीं, तो यहाँ पे ये रोटेशन 0 होगा. तो फ्रॉम द डायग्राम I may write here MA L over 6EI plus 0, because ये स्पान पे दिस इज ड्यू टू MA राइट साइड में रोटेशन होगा. इफ यू लुक एट द डायग्राम, राइट साइड में रोटेशन है बट मेरा स्पान अलग हो जा रहा है जहां पे कोई भी मोमेंट नहीं है, देन आई हैव टू मेक इट 0. सिमिलरली द लास्ट केस में यहां पे देखो ये रोटेशन हमें कैलकुलेट करने हैं. सो दिस रोटेशन विल बी थीटा 1 डबल डैश, ओके, ड्यू टू स्पान BC, क्योंकि AB में कुछ नहीं है तो AB में ये रोटेशन 0 होगा. So theta 1 double dash due to AB will be 0 and theta 1 double dash due to BC will be what? Half of this, मतलब फार एंड है इसलिए MB तो यहाँ पे लग रहा है और ये फॉर्मूला कैसे है, जो फार एंड है वहां पे ML over 6EI है, तो यहाँ पे जो रोटेशन है ये जगह पे ये रोटेशन, this rotation will be 0 but this rotation will be MBL over 6EI. So we may write MBL over 6EI. And the last one, theta 2 double dash, right? So theta 2 double dash due to span BC, theta 2 double dash due to span CD. So it will be a summation, of course, summation of these two rotations due to moment. Okay, so ML over 3EI, यहाँ पे MB over 3EI, MBL over 3EI आएगा, एक रोटेशन ये होगा, दूसरा रोटेशन अगेन MBL over 3EI होगा, तो 2 times MBL over 3EI, MBL over 3EI, so 2 times आ गया. Now we write the compatibility question. हमारा कैलकुलेशन हो गया, लिखना हो गया, ये calculated rotation. Now joint compatibility. So we will write one compatibility equation at one single point, that is joint B. तो joint B पे जितने भी rotations है आपको ऐड कर देने हैं. तो you add rotations, joint C पे जितने भी rotations है that we will be adding. So first compatibility equation you will be using this equation. So theta 1 AB plus second compatibility equation is what? Theta 1 dash AB, and due to theta 1 dash due to BC also. So theta 1, this is a combination of, you are adding theta 1 due to span BC, right? And second theta 1 dash due to AB, theta 1 dash due to BC plus last one, that is theta 1 double dash due to AB, theta 1 double dash due to BC. So this is your joint compatibility at joint B. And the original beam, there are no rotations, so I can make this equation. This is a single equation. Only thing is why this plus sign I have written, because it's a combination of two rotations, right? So पहले equation में ये आपको लिखना है Q. So what is the final formula? QL cube over 24 EI plus PL square by 16 EI plus theta 1 dash AB, theta 1 dash ये. So 2 times MA L over 3 EI plus due to due to AB ये एक आ गया, and due to BC it is anyway it is being added, then theta 1 double dash AB is 0, but BC से आएगा MB theta 1 double dash 1 है, यहाँ पे देखो 1 theta 1 double dash due to BC is MBL by 6 EI. So plus this is equal to 0. This is my joint compatibility equation at joint B. You draw the diagram properly again so that it is more clear. There should not be any confusion. In addition, जब आप ऐड करते हो आपको जॉइंट पी पे जितने रोटेशन हमने कैलकुलेट किए वो सारे ऐड करना है. Okay, now second compatibility equation at joint C is, I will complete this after writing, and then you know the next procedure, right? Tomorrow we can recap little bit and then we can start a new topic, but I'll recap this little bit so that you understand. So joint equation 1 लिख दिए, यहाँ पे एम ए एम बी एक अननोन आ गए, दूसरे इक्वेशन आएगा उसमें भी एम ए एम बी आएगा. आप दोनों इक्वेशन साइमल्टेनियसली सॉल्व करोगे तो आपको एम ए एम बी इंटरनल बेंडिंग मोमेंट आपको मिल जाएगी. तो दूसरा इक्वेशन कैसे लिखोगे? जॉइंट सी पे, जॉइंट सी पे क्या क्या है हमारे अननोन? थीटा 2 डैश ड्यू टू बी सी एंड सी डी. ओके, सो थीटा 2 डैश इज दिस ड्यू टू बी सी is this, and CD due to CD is this. So first is this MAL by 6 EI plus theta 2 double dash due to BC, that is MBL over 3 EI, and due to CD it is MBL over 3 EI. So 2 times MBL over 3 EI plus पहले का, तो पहले का थीटा 2 क्या था? ये रहा थीटा 2 B due to BC and due to CD. So this equation we have to add. So it is PL square by 16 EI 2 times plus PL square by 16 EI plus PL square by 16 EI. So this is my second equation, and you will see some analogy in both the equation. जहाँ पे मेरा MB MA था 3 EI, ठीक है, वहाँ पे okay, I hope I have written MA MB properly. Just let me check. MB जहाँ पे MB लिखना था MB लिखना है. Okay, here it is theta 2 is MA. This is correct. This is also correct. ये 2 times आएगा यहाँ पे. This is correct. This is correct. Theta 2 BC MA. This is also correct. Theta 2 BC is also correct. But एक जगह पे MA आना चाहिए था. Sorry. No, I think it is okay. Okay, so you can see the reverse thing in both the cases. Just compare these two equations. This equation and this equation. Compare these two equations. यहाँ पे MA 2 times MA L over 3 आ रहा है. यहाँ पे 2 times MB over 3 आ रहा है. और यहाँ पे एम बी एल ओवर 6 आई, जबकि यहाँ पे एम ए एल ओवर 6 आई, और बाकी जो लोडिंग के टर्म से है जो। So these two compatibility question, एक joint B पे, एक joint C पे, these two simultaneous equation you have to solve, and this complete our example. So I think we have next class, so I can end this meeting. Tomorrow we are meeting again. I will little bit recap and we start a new topic. Okay, so all of you please start thinking in, I have discussed everything which are required to solve in your assignment examples. I have discussed everything, right? So there should not be any confusion. If you have any doubt, just let me know. You can ask me. Even in while solving, if you have doubt in between, just you can write me the message, and I can help you if I can help. Okay, so just try to take initiative in solving at least example 1 से शुरू करो आप solve करना, आपको खुद को practice करनी है, आप practice करोगे तभी आप exam में लिख पाओगे. Okay, so we will now end this meeting now. Any questions, anything, any doubt? समझ में आया क्या करना है? Have you? Yeah. So I think we can end this meeting now.